Hi, I'm Len Epp from LeanPub, and in this Lean Publishing podcast, I'll be interviewing Brian Caffo. Brian is a professor at the Department of Biostatistics at the Bloomberg School of Public Health at Johns Hopkins University and director of the graduate program at JHU Biostatistics. Brian works in the fields of computational statistics and neuroinformatics and is a co-founder of the SMART working group at Hopkins Biostatistics, which specializes in medical and especially neurological imaging and biosignals such as polysomnography and wearable computing. In 2011, he was among the recipients of the Presidential Early Career Award for Scientists and Engineers and the first statistician to receive such an award. Brian has also received the Bloomberg School of Public Health Golden Apple and AMTRA Teaching Awards. Brian is the author of two LeanPub books, Statistical Inference for Data Science and Regression Models for Data Science in R. Each book offers a brief but rigorous treatment of statistical inference and regression models respectively and is intended for practicing data scientists. Both books are companions to classes offered as part of the data science specialization on Coursera, a 10-course program offered by Brian and his colleagues at Johns Hopkins, Jeff Leake and Roger Peng. In this interview, we're going to talk about Brian's professional interests, his books, his experiences using LeanPub, and ways we can improve LeanPub for him and other authors. So thank you, Brian, for being on the Lean Publishing podcast.
Thank you. It's great. It's great to talk with you and meet you.
Thanks. So I usually like to start these interviews by asking people for their origin story to learn how they got to where they are in their careers and how they developed their interests. So I'm wondering specifically how you first became interested in biostatistics and why you decided to pursue a career in academia.
Well, so the long version of this story is when I was in college, I was actually a swimmer in college. I wasn't a terribly good swimmer, but I was on a big team. I was at the University of Florida, which has a great swimming program, and I was an art major at the time, and I was spending so much time training that I didn't have a ton of time to actually put into being an art major, which is a surprisingly difficult major, especially in terms of time. I had an aptitude for mathematics, so I kept taking math classes, maybe a little bit lower level than I needed to, but then just kept incrementally doing it to kind of fill out my hours so that I could have some classes to be able to manage swimming and trying to do the art major. And finally, after doing this for long enough, I talked to a guidance counselor, and they said, we typically don't get too many art majors who are taking differential equations and linear algebra and these sorts of subjects. And she said, you seem to be actually doing better in those than you are doing in your art classes. And she said, you can always do it in your spare time. And so from there, I switched over to become a math major, and from mathematics, I'd spent some time studying, working with the Children's Oncology Group, which was then centered in Gainesville at the University of Florida, where I was at. And from there, I just really fell in love with with working with data and the kind of computing and mathematics that goes along with statistics. And just staying in academics for me was in a lot of ways a no-brainer. I really loved the things that I was doing, and I loved the kind of research that I was doing, and I was very fortunate to get a position here at Hopkins where I have such amazing access to great data, great researchers, great medical research, and so that's the long version of my origin story.
Okay, thanks. That's very good. It's an interesting path. I was wondering if you could explain some of the reasons you co-founded the SMART working group and what the purpose of the group is.
Yeah, so originally, this was co-founded with a collaborator here, Ciprian Craniceanu, and we had a lot of similar interest in terms of how we approach modeling and how we approach statistics. And we were getting a lot of people coming to us, talking to us about some new kind of measurement that they were collecting. So in my case, it was mostly brain imaging measurements. And you might think that there's only a couple of ways that you can measure the brain, and that idea couldn't possibly be more wrong. Just even with one type of scanner, a magnetic resonance imaging scanner, there are so many different ways you can tweak an MRI scanner to give you different kinds of signals in the brain that you can barely count them. And so, at any rate, both in terms of brain imaging, but also things like sleep studies and polysomnograms, they're called, as well as other kinds of wearable computing things. We were constantly getting people coming to us and talking to us about how do I analyze this kind of data, especially, because we're here at a school of public health, we're here at a medical institution. People wanted to relate these measurements to disease. They wanted to create preventions and prognoses, and I'm in a school of public health. People wanted to relate it to large populations, and they didn't know how to do it. It involves a lot of computing, mathematics, statistics, and so we noticed a kind of common thread of some sort of biological signals or biosignals, and we founded the group out of it. And initially, it was a group with air quotes around it. And then after enough faculty kind of joined in and enough students joined in, we started having alumni from the group and postdocs and things like that. It's now become a rather large entity. When we have a full group meeting, which we don't have that often anymore because it's gotten so unwieldy, maybe 35 or 40 people will show up.
Wow, that's great. Can you explain a little bit about what a biosignal is and maybe give an example of one?
So we kind of take a biosignal basically to any biological or medical signal that is used to create a diagnosis or to create a measurement that is then used for research purposes. That's and which is a very broad definition. An important an important class of biosignals that we don't really delve into too much in our work is the field of computational genomics and high throughput bioinformatics. So we don't do too much of that. There's a lot of different interesting kinds of measurements that go on there, but we kind of broadly classify it, and we did it that way because around here and around Hopkins there were large developed bioinformatics groups because there was so much excitement over the sequencing of the human genome, but a lot of these other technological revolutions were kind of getting left behind in terms of analysis skills, so we sort of lumped them all together. And so, yeah, I agree that things like biosignals are kind of a vague term, but now that we've gotten big enough, we need to maybe make them more precise and define ourselves a little better.
Oh no, fair enough. I was just wondering, so for example, is like something people might be familiar with, like rapid eye movement. Does that count as a biosignal, or like measuring eye movements?
Yeah, so there you're talking about in sleep. So sleep is typically measured if you get a rigorous sleep study. That's called a polysomnogram. And so the collection of biosignals that they would collect in that case would be electroencephalogram. They put electrodes on your head that collects kind of brain activity. They have things like a myogram that they would put, for example, on your chest that would detect like breathing, and that's detecting motion a little bit. They might have some motion sensor that they're putting on your leg for restless leg syndrome. They might have oxygen, something that measures oxygen that they would put on your finger. And they might put an EKG on if, in most of the sleep studies we were looking at, they were very interested in cardiac outcomes associated with different kinds of sleep disorders. And so they might have an EKG on. So specifically, when you talk about REM, what you're talking about is the collection of measurements. And then for a diagnostic sleep study, they have things that are going to measure things about your breathing. REM is a specific classification of a sleep state, and that arises from subsets of these biosignals that they use to then classify different kinds of sleep, deep sleep, different stages of sleep and REM. That's an important aspect of the measurement. Usually, they actually have to go. They have to take them and pass them through a human to get the staging like that. But as an example, we have several papers on analyzing the percent of the time that you spend in REM over the course of an evening, things that they call things like sleep architecture. So we often think about how if you're tired for several days straight, you might think you might catch up on sleep or something like that, and that relates to things like sleep efficiency and sleep architecture and these sorts of things that we get out of those signals. So going from those signals to these measurements and relating them to diseases in the population is really what we try to do.
And you've done work with signals that come directly from the brain, where you've implanted electrodes directly on the brain as well. Is that correct?
Yeah, so that kind of measurement, the one kind of measurement like that I've dealt with is called electrocorticography, and that's something they do for people with pretty severe epilepsy, where different medications and other kinds of treatments have failed, and they're left with nothing other than brain surgery. They saw off the top of their head. And as a measure to help inform the surgery, they place this electrode sheet directly on the cortex. And then usually there's some time between the early parts of the surgery and then the actual brain surgery part. And so the people often let some amount of experimentation go on in terms of maybe playing sounds or having them do things and then recording the brain activity while that's going on. So yeah, in some rare cases you can actually collect human measurements from otherwise healthy humans who have some severe disorder like epilepsy, where the measurements are directly implanted on the brain. I don't personally do this, but there's also a lot of people around here who study mice and monkeys and other things where they actually implant the electrodes. So these aren't implanted. This rest on top of the cortex. There are other people who do things. There's a fascinating field called machine-brain interface, where people are implanting electrodes in monkey brains, and they're getting the monkeys to like feed themselves based with a robotic arm, just the robotic arm being controlled by the electrodes directly implanted in the brain. So that's a there's tons of neat areas where there's actually direct implantation of the electrodes, but that only occurs in these more invasive things that people do on animals. I almost exclusively work on human data.
I've read also that the Smart Working Group uses brain imaging for prediction, and I was wondering if you could explain a little bit about what brain imaging is and how it can be used to predict behaviors.
So the kind of brain imaging that I work on is so-called functional magnetic resonance imaging, and in that you don't get a static image, you get a dynamic image that represents, hopefully, brain activity, localized brain activity over time. And there's a lot of different ways that people might use both this kind of measurement and other kinds of brain measurements for prediction. So as an example, a colleague that I'm working with right now wants to use brain activity as measured by fMRI plus some structural measurements in people who are in comas to try and predict when they'll come out of it, or if they'll come out of it, and the prognosis. And so that's an example of using brain imaging as a biomarker to predict some outcome. There's another, I don't do too much of this, but a colleague of mine in the Smart Working Group, someone who we managed to successfully recruit to the university, a extremely well-known fMRI researcher, Martin Lindquist. He works on actually trying to predict what's going on in your head with the information from the scanner at that moment. So in particular, he works on pain. So he tries to predict how, they have people in the scanner and they actually deliver pain to them by a hot, plate or something that's resting on their wrist. So it actually stings a little bit. And they he tries to predict how hot it was on the plate just based exactly on the brain signal and things like that. So and that has implications for trying to understand, how we can get a better measurement of pain, right? When people just say, oh, something hurts, a physician doesn't know what that means, but if they can calibrate it. So he's working toward the idea of actual prediction of pain. So that's another way that you could use these kinds of measurements for prediction. And there's quite a few. So we do some of. I tend to more focus on the public healthy type prediction type things of where we try to predict whether or not a person has a disease, whether or not they'll come out of the coma, is another example. these sorts of things where the image is just a collection of a part of the measurement. A really big one that everyone's working on right now is trying to predict who will get Alzheimer's disease. And the reason being that if you can detect Alzheimer's disease early, then you have a much better chance of being able to develop an effective treatment.
Generally, on the subject of gathering data, I was wondering if you had any comments about the impact that wearable computing is going to have on public health generally, and perhaps on your field specifically.
It's going to be huge. It's going to be huge. And the SMART group does a lot of wearable computing work. Personally, I don't do too much, but my colleague Ciprian, who co-founded the group with me, along with some others in the group, have really, dove into wearable computing in a big way. And there's so many different kinds. I mean, people, when you think of wearable computing, I think people tend to think of things like Fitbit and stuff like that. But for research purposes, there's a million different kinds of sensors and measurements that people can take that are now small enough and portable enough, and it is just amazing. And I think it's going to revolutionize public health in terms of our ability to get accurate measurements for lots of different things. And the key bottleneck is having enough people who know how to analyze this stuff. Where our ability to collect data is just so vastly outstripping our ability to analyze it. And so we see actually the bigger problem is not the development of the sensors and stuff like that, because lots of smart people are working on that and they're developing great stuff. But then so much data gets produced, and the real bottleneck now is people to analyze the data. So I would say to anyone who's a aspiring young machine learner or computer science statistician or biostatistician or anything like that, it's a great field to get into.
I was going to ask on that subject. Generally speaking, statistics seems to be sort of enjoying a cultural moment with the popularity of sports and election statistics, and most commonly associated in North America with people like Nate Silver. And I was wondering if you think that this specifically is going to inspire more people to get into things like data science, and if data literacy generally will improve as we go forward, say if we're all wearing Fitbits or things like that.
Well, I think this cultural revolution is really, for sure, is helping. Like Moneyball, the book, is a great example. Like Nate Silver. Yeah, that cultural revolution is great, and is really going to help out our field and this closely related field. But I think the bigger impetus for drawing people into the field is the demand for jobs in the field. I think the fact that it's one of the relatively few sectors where there's an enormous amount of job growth, and that there's way more demand than supply, and there's no apparent harvesting that's happening, that there's no leveling off that seems to be eventually the case, that we're just in new kind of data-oriented companies seem to be popping up every day, and giant companies, all your Googles and Facebooks and Twitters and everyone, they're ostensibly data companies at some level. And so I think the major draw for people into this field will be the fact that it is going to be one of the principal jobs of the future, which when I got into it, when I was a lowly art major trying to figure out what to do, there weren't all different kinds of options, and it's interesting now we see our students. The amount of options that our students have now is truly remarkable. Some of them go into finance, some of them go into technology and move off to Silicon Valley, and some of them stay in academics, some of them do biostatistics, some of them go to mathematics. The number of options they have now is remarkable.
I read on your website that you have a particular interest in large-scale open access education, and I know, of course, that you've been quite successful with the data specialization course on Coursera. I was wondering what inspired your interest in open access education and what plans you might have going forward.
Well, so this LeanPub fits really, really well into our vision, and I'll get to that in a second. So initially, it was really just kind of fortuitous. I had wanted to flip my classroom, which is the process where students watch videos at home, the lecture at home, but during the class period, they actually get more of my time and the TA's time in actually doing problems. And there's a lot of work so far that's showing that that's a more effective way to teach people, and that the old sage on the stage lecture model is not the optimal way to do things. So when I contacted some people to do some recording in our school, they mentioned that we had just struck a deal with this open access, open education company called Coursera, and asked if whether I'd like to be one of the people in the launch. And so I agreed. I was really enthusiastic about it, and I happily went and then talked to Roger and Jeff, who are my two colleagues here, who were very interested in it as well. And I think my class was okay. Their classes were just blockbusters. And from then on, our interest was really peaked, and for a variety of reasons. But one of which being this idea of delivering low cost or free education is very appealing to people in academics. So I think that the books, LeanPub in particular, has really helped us in terms of kind of fitting into that model. So our Coursera model for all of our courses is everything's free. The lecture notes are all posted on GitHub, and you can see the full development process. The videos are all free, both on Coursera, and you can get them off of YouTube for most of us as well. And it just makes sense too that the textbook, if there was a textbook that existed for these classes, that should also have a free option or a variable or something that some new way for doing the pricing, so that it it conformed to this new model, and it conforms great. So and in LeanPub for textbook especially because we can basically give the students edition updates and things like that, and a lot of things that people would complain about university textbooks just get all solved all at once. So it fit actually pretty well with our kind of open education mission. So I don't know how I got interested into it, other than this series of events, and that it kind of always kind of fell well within my kind of personal ethic, and I think same with Roger and Jeff. I would also mention that the school was a very early pioneer for open education. Well before Coursera and before Khan Academy and things like that, there was MIT OpenCourseWare, and our school was a participant in MIT OpenCourseWare, and I was in on some of those meetings where they were deciding to do it, and I was super enthusiastic about it at that time as well. This was quite a while ago. So I think the school has really been on the School of Public Health here has really been on the vanguard of open education, and it's part of being part of that culture kind of seeps in as well.
It's really interesting. I know there are some voices out there that respond relatively conservatively to the idea of open education, and in particular they'll invoke the possibility that it might be a competitor or a threat to conventional university education. And I was wondering what your response might be to that criticism.
For sure, it's possible it might be a threat to certain financial models for certain departments for certain topics. But by and large, it's the question is whether or not these are coming up with new markets or they're poaching existing markets. I think the vast majority of the ways in which the students take these classes are new markets. They might be university students, but a student might sign up for a machine learning class that they may not have taken on Coursera at their university otherwise. So I think probably the majority of the student engagement on Coursera, edX, Udemy, these other sites is probably new users. But for sure there is a certain amount of poaching that also has to occur. That student that was going to take that elective class elects to just take it on Coursera or something like that. I'm sure that to some extent that is happening a little bit, but it's not all that dissimilar from the correspondence courses and other historic attempts over time to broaden access to education in different ways for people who have different circumstances. I think a lot of that focus on how online education is going to disrupt universities is a laser beam focus on 18 to 22-year-olds in undergraduate education, but the people who take these classes exist well into their work life, well beyond their university life, and so I think it's a lot more complex than that. I think there's a certain amount of disruption that's occurring because of it, but I think it's in a lot of ways good disruption. I think the one way in which maybe the kind of disruption that you're talking about might occur is any place that really has a revenue model where they use large introductory classes as a revenue generating component with adjuncts to generate the revenue that they use for other things. If they don't have a very diverse kind of financial model, that might get disrupted. But even that, I don't see that much. People like in-person classes, so I just don't. I just don't see how much. I do think most of it is new users and new content. But I am a university professor. At some level, I'm dependent on brick and mortar learning as well. Not on some level, on exactly every level.
On the subject of generating revenue and textbooks in academia, I was just wondering if you, and also journal articles, I was wondering how you see academic publishing evolving, say, over the next few years, and if there's going to be a shift, sort of, perhaps along the lines of what's happening towards open access education with video tutorials and things like that.
I feel a little bit more confident that something like LeanPub is going to disrupt traditional book publishing than I am about what will happen with traditional universities with respect to online teaching, because our experience with LeanPub has just shown that if you have your own channels to get your book out there, then it is really an ideal circumstance. And you can, if you're willing to publish something as purely as an ebook, or mostly as an ebook, then you can do all sorts of interesting things with embedded videos. So in my stat inference book, not all, but most of the homework problems have links to YouTube videos that actually give the solutions. With me working them out, like I have a little tablet here that I hand write out the solutions as I record myself doing them, and that kind of disruption seems pretty inevitable to me at this point. For journal publishing, I'm less certain about. I don't know a lot about the journal publishing business. I guess I don't really know much about the book publishing business either. But from my experience as an author, I can't even imagine contacting a traditional publisher at this point. But for journal publishing, that's I still submit articles to the journals that everyone thinks. I submit my best articles to what I think are the best journals that'll take them, and I don't know about disrupt. There's a lot of discussion in academics right now about discussion of academic publishing, and there's a lot of new models that are coming out. I must say many of them are really impressive. Like Frontiers is an example of one that I've worked with that I think is quite impressive, and PLOS is another example that's quite impressive. But I have a less clear picture in my mind of how that will shake out.
I know that in both of your books on LeanPub, you mentioned that people are invited to send you errata or with pull requests on GitHub and things like that. And I was wondering if engaging directly with people who've already bought your book is important to you, and if there's anything we could do at LeanPub to help you engage better with your readers online.
Yeah, so I like the fact that I, if I decide to add an extra, section or a chapter or, new set of problems or something like that, I I like the fact that the publishing allows me to, and LeanPub allows me to contact everyone who's bought the book and tell them. So sometimes I'll republish the book and I'll just send out I'll send out an email to everyone that just says, I'm republishing the book. This is minor stuff. Don't bother reloading, re-downloading it and putting on your devices, for this. But then sometimes I'll put a whole new section or chapter in, and I'll be like, this is probably worth re-downloading if you're still actively engaged in the book. So the ability to contact people, I think, is quite useful. And they might want to, people who bought the inference book might want to get the regression one. So the ability to email them out and say it and say to do that is great. So I think that's a nice aspect of having direct access to the customers. And the GitHub integration, so the students submit pull request on GitHub, then I'll correct that error. So it's not like they're emailing me errata; they're submitting it as a pull request. I'll accept the pull request. I have one of the switches on GitHub that whenever I check something in, it automatically recompiles it on LeanPub. So they'll submit a pull request. I'll accept the pull request. When I recommit the repository, repush the repository, then it automatically gets recompiled on LeanPub. Then I have to republish the book if which I'll only do every now and then when it's a big enough set of changes. But that's actually really great because it's not like I'm getting a ton of emails. I'm getting it's working through on GitHub, which is fantastic.
And specifically with respect to emailing readers, we actually do a kind of sort of double blind where we don't reveal the reader's email address to the author or the author's email address to the
That's
reader.
right.
We're kind of a middleman. And do you see that as a good thing, or does it bother you that you can't see the actual email addresses unless they opt into that?
I think it's sort of irrelevant to me. I mean, if I had a list of emails, I wouldn't do anything with it. So it would just be, if I actually had to manage the emails, that would be kind of an annoyance. So it's kind of useful. But then also from the consumer side, it seems like a nice protection of their identity and their information. So
Okay.
that seems pretty reasonable.
Okay.
And I don't have any need for their email otherwise. So yeah.
Okay.
It seems like the right way to do it.
Okay, great. I was wondering if there's anything specific that you think we could improve in your workflow, or for the way you like to write and to contact readers, for example, if there's anything specifically that's come up.
Well, so for the data science specialization, we actually wrote all the lecture notes in Markdown. So the ability to convert the lecture notes into a kind of what I think of the stuff I'm doing is more kind of like lecture text, right? So it's sort of it's highly connected to the class, right? It's sort of a standalone book, but it's mostly connected to the class. But the ability to kind of create that kind of entity in Markdown, because LeanPub, the authoring is in Markdown, was very seamless, and that helped out. That helped a lot. One instance where I think things could be improved is if you could author directly in LaTeX. I noticed that LeanPub apparently does Markdown and then probably does Pandoc to create a LaTeX file, which it then LaTeX. I'm pretty confident I'm seeing in the log file standard LaTeX compiling. So if there's some way you could actually author in LaTeX for the math, science, computer science, stat crowd, LaTeX is the lingua franca of the community. So people already know it. That's one thing. The other thing would be access to the log files after it gets compiled. That would be very useful because when it comes in an email, that's just a timing thing. But I think another useful thing would be an offline compiler or something that was close enough to where you could compile it offline. So a combination like a Pandoc, a collection of Pandoc commands or something like that said, oh yeah, take this, do this to your Markdown file, and this will approximate pretty well whether or not you'll get an error. I think that so that you can kind of write and rapidly debug. I've noticed the only time I ever get an error while compiling is with equations. That's it. So so for certain subjects, that's no problem. But for inference, it was a little that part was a little hard fortunately, I already knew the math was already typeset without errors for LaTeX to begin with, so that was helpful. But for writing a de novo book, something that would allow you kind of a quicker ability to debug errors in the math typesetting, that would be helpful.
Okay, well, yeah, thanks very much for that. We're actually going to be working on an author app, and hopefully that, a lot of that will be incorporated into it when we do that, because we want to make it easier for people to work on their own machines.
Sure. And the other thing, yeah, and I've never tried it, but I another solution in my particular case would just be to convert it to EPUB myself and then upload it as an EPUB file.
Oh, okay.
I noticed you guys just accept an EPUB file by itself.
Yes, that's correct.
Yeah, so I could author it in LaTeX, pandoc it to an EPUB file, and then just submit the EPUB file. So I've never tried that solution.
I just have one last question. Are you working on any other books right now that you plan on publishing?
So yeah, if you look, I don't know how often you look in people's accounts. I've got about 7 queued up. So I teach 3 classes as part of the specialization. So I've done 2 of them, inference and regression. I've got to finish up regression. I'd classify regression. I think on the slider on EPUB it says maybe 70%. I'd like to get it up to 100%. And then after I've finished with regression, I teach a 3rd class in the specialization called developing data products. I'd like to finish that one. That will be, because it's a computer-oriented book, that will be really ideal for the LeanPub authoring and setting. And then after that, I have 2 Coursera classes that are coming out that I hope to create. My new strategy is to write the LeanPub book, then record the videos, and then release the class. The reason being is that the LeanPub book will almost then serve as a script for the videos and then for the class. So we're thinking of that in terms of the workflow.
That's just really interesting. I'm so glad to hear that you're using LeanPub that way. I mean, it's one of the things we always hoped it would be used for. I'd just like to say, before we go, thank you very much, Brian, for being on the Lean Publishing Podcast and for being a LeanPub author.
Oh yeah, thank you. We've had a blast. It's been really fun. It's been really fun working with the platform, and I'm a big proselytizer for LeanPub at this point. Our experience has been great. So thank you guys for creating such a great product.
Thanks very much.